Okay, guys, our last lesson is kind of bringing everything together that we've learned, and we're going to solve problems with sinusoidal functions. So this is where we take everything that we've learned about sinusoidal functions and graphing them and how their equations look and apply them to real life examples. So let's go right into the example. The key concepts are there. The graph shows a daily high temperature as recorded every 30 days for the town of Sydenham for 2 years. Does this graph appear to be periodic? Explain why. Determine the amplitude of the function. Determine the period of the function. What does the period represent in this context? And what might be true about a town for which the graph has a significantly smaller amplitude? So let's take a look at the graph. And the first question says, is this appear to be periodic? And explain. So just looking at it, I notice that this graph, if we connect the dots, goes up, comes back down, goes back up, comes back down. Now that is over a period of 840 days, which is over a year. It's over 2 years actually, but you'll notice that because it goes up, comes back down, goes up, comes back down, this is a periodic function. So I'm going to say for A, yes, it appears to be periodic. And you can say why. The graph goes up and down over a period and always comes back to the starting. Determine the period of the function. First, determine the amplitude of the function. So the amplitude, first, when you find the amplitude, you need to find the middle of the graph. And the middle is, so the highest point is 24 and the lowest is down here. The middle is about here. Probably around 11. And so when you think about that and you think about the difference between 24 and 11, our amplitude is approximately 13. Let's make sure that that's kind of correct. I might actually do it that it's approximately 12 or 13 because you kind of want to divide the 24 and the 2 in half. So I'm actually going to move it up a little bit higher. I'm sorry, guys. Let's erase that line because I think that it should be a little bit higher. So I'm going to change it to approximately 11. Because that gives us an even on each side on the top part and the bottom. C, determine the period of the function. So the period of the function looks like, so it's at the bottom here at 0 days, and then it looks again like it's at the bottom at like around 480. And then again, so I'm going to say it's approximately, or you can do the difference between the top part, just as long as you have it, where does it start and where does it come back to that. So it's looking like it's around 400 days. 400 to 420 days. What does it represent in this context? Now, because we're talking about daily high temperatures and day numbers, it represents a year in this context. What might be true about a town for which the graph has a significantly smaller amplitude? If it's a smaller amplitude, it might be somewhere where the temperature is not so drastic. Like, notice that this one goes from 0 to 24. If it has a smaller amplitude, it's probably somewhere where the weather is more consistent through the year. So it might be somewhere like Florida or California. So I would just say a place where temperature, sorry about the noise in the background, guys, where temp is more consistent. And I might then say, like, e.g., Florida or California or somewhere where it's warmer. California. I have at the bottom here some strategies for solving sinusoidal functions. So the first thing I say is make a graph if you can. It makes it visually easier to see what is actually going on. Use the graph, answer the questions according to the graph you have drawn or produced, and think about how it could be answered using sine or cosine. Which one is most comfortable for you? Both equations are acceptable to use. If you have to give an equation, I'll accept an answer that has sine in it, and I'll also accept an answer that has cosine in it, as long as you have your phase shifts correct. Okay? That's pretty much all that's going on with this lesson. Try the different examples, get used to different sinusoidal representations and how it can be used in the real world. And I'll see you guys later.